Hi, and welcome to this lesson. We're looking at escape velocity today. So we'll start by defining what escape velocity is. Escape velocity is the velocity required to escape the gravitational pull of the Earth, basically going from the surface to infinity. So at the escape velocity, the kinetic energy of the object has to be equal to the GPE required to get to infinity. So let's start our derivation. So we're going to start with this idea of conservation of energy. So half mv squared, the kinetic energy, is equal to the change in work done in moving to infinity. So delta W, we know from our equation sheet, is equal to m delta V, where V is the potential. And we know that at infinity, the potential is equal to 0. That will make things simpler for us. At any other point, we can check on our data sheet and get the equation for V, which is V is equal to minus gm over r. Okay, so if we substitute that into the equation for delta W, we get delta W is equal to m times 0 for infinity minus gm over r. And then we can simplify that down, so W equals m gm over r. Okay, then we're ready to substitute that back into our original equation. So half mv squared is going to be equal to gmm over r. And our little m's cancel out. So we get v squared is equal to 2gm over r, and then we can square root that to get the escape velocity is equal to the square root of 2gm over r. You have to be able to do that derivation. Okay, so just checking we've got the right answer there. Have a go at some questions. Let me know if you have any problems.